Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Even Platform and it's by Pagodo. And here are the rules, or Pagado. I'm not sure if it's Page or Pagado. I don't know. It's one of those, maybe. Could be some other pronunciation too. Anyways, here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. Also, cells with gray squares contain even digits. So all these gray squares are even digits. Box borders divides blue region sum lines into segments with the same sum. And there's only one region sum line, so therefore these three cells must add up to the same as these three cells, which must add up to the same sum. So these three cells add up to the same sum as these three cells, which add up to the same sum as these four cells, which add up to the same sum as these four cells, which add up to the same sum as these five cells, etc., right? It goes all the way through. And it all must add up to the same as these two cells here. And that's how region sum lines work. Also, we have cells joined by an X sum to 10, and cells joined by a V sum to 5. So for example, if this was, say, an 8, not a yellow, an 8, it would have to be a 2, because these two digits have to add up to 10. Similarly, if this were a 3, this would have to be a 2, because these digits have to add up to 5. And cells joined by a white dot are consecutive. And not all x's, v's, or dots are given. So for example, if this was, say, a 6, this would have to be a 5 or a 7 to make sure that these digits are consecutive with each other. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the first thing I see is, again, these two digits must sum up to what all of the different region sums have to add up to. Well, we have also 5-digit sums on this region sum line, so it has to be at least 15. So this must be at least 15. But these 4 digits add up to 10 because 2 of them add up to 5 and these 2 add up to 5, so that's 10 total. Which means, and this one is next to an X and it cannot be 5. So we know for certain this has to add up to at least 16 because 5 cannot be next to an X, because if you have 5 next to an X, what digit can you add up with the 5 to add up to 10? It's 5 only, and that would break normal Sudoku rules. So this has to be 6 or 7, which makes this 3 or 4. This is a 2. This is either 2 or 4. This is 2 or 4, which means this has to be 1 or 3, and this has to be 1 or 3. Therefore, we know these two digits add up to at least 16, and it could be 17, right? 17 is the max for 2 digits, which is 8 and 9. But if you have 16, you would have 7 and 9. But the problem is neither 7 nor 9 is even, and we know one of these digits is even. So this must be 8, which makes this a 9. So that's 17. Therefore, this sum along the region sum line, all of the sums are 17. So therefore, this is 10. This must be a 7. So this is 7, which makes this 3. 3 adds up with 7 to add up to 10. 3 adds up with 2 to add up to 5. This adds up to 10, so therefore this must be a 7 to add up to 17. So this is 7. These two, let's see. These two add up to 10, so these two must add up to 7. So it's either 1, 6, 2, 5, or 3, 4 here. We know this adds up to 17, these 3 add up to 17, and these 3 add up to 17. That gives us 17 plus 7, wait. Does that work? Hold up. We have a problem here. This is 17, 17, and... Oh, this is not 17. The whole thing is 17, but this 3 is not 17. Okay, that's why. That doesn't work that way. Okay, so never mind. This has to be 1, 2, 3, and 4 as a possibility. But this can't be 3, so this can't be 2. So therefore, this is either 1, 9, 3, 7, or 4, 6. These are consecutive. If this is 1, it would have to be 2 here, but that's not possible because of this 2. So this can't be 1, this can't be 4, this can't be 6 then. This is 2 or 4. If this is 2, this would have to be 3, therefore this would be 1. If this is 4, it could be 3 or 5 here. Interesting. Anyways, these sets of 10 cannot have 2 and 8 or 3 and 7, so it must be 1, 4, 6, and 9. Which means these digits have to be 5 and 8. Okay, well, we have a 5, 8 pair now in column 3, which eliminates 5 and 8 in the rest of the column. Therefore, this can't be 8. What's consecutive with 7? Besides 8, it is a 6. So this is 6. This has to add up to 5, so it's 1, 2, 3, or 4. This has to be 2, 4, or 6, actually. So, we have a 2, 4, 6 triplet now. Okay, this has to add up. It's either 1, 2, 3, 4, 7, which adds up to 17, or 1, 2, 3, 5, 6. Either way, 1, 2, so this could be 2, 4, 6 here. Either way, this has to be 1, 2, 3, and we could have 4, 5, 6, 7 along here. But this can't be 2, 4, or 6 because of the 2, 4, 6 triplet in row 2, which eliminates 2, 4, and 6 in the rest of the row, whereas 8 also in this row. It has to be one of these two, which means 8 has to be one of these two here. This adds up to 17. This adds up to 5, so therefore this adds up to 12, because 17 minus 5 is 12. Therefore, it could be 3, 9, 4, 8, or 5, 7, but it has to have an even digit, so it must be 4 and 8. So this is 4 and 8, which means which eliminates 4 and 8 in the rest of the box, because we have a 4, 8 pair. Therefore, this can't be 4 or 8, it's 1 or 4. It can't be 1 or 4 because of the 4, 8, so it's 2 and 3. The 2 and 3 is next to 1, 2, 3, or 4. But we have a 2, 3, 2, 3 pair in row 8, which eliminates 2 and 3, so this can't be 2 or 3. This can't be 4, and this can't be 4. The remaining digits here can be... It cannot be 2 or 8. It could be 1 with 9. It can't be 3, 7, because the 7's eliminated by these 7's here. Can't be 2 or 8, because neither of these can be 2 or 8, because of the 2, 3 pair, 4, 8 pair in the box. I guess this could be 1 also, and this is 9. And it could be 4, 6 if this is 4 and this is 6. Okay. One of these can't be 7, so one of these has to be a 7 here. Which means where's a 7 in row 8? Cannot be any of these, cannot be any of these, so it must be one of these. It can't be here, it has to be here. So this is a 7. That means the remaining digits add up to 10. And this cannot be 6. So this must be 2 or 4. It can't be 2 because of the 2, 3 pair. It can't be 8, obviously, because then that would require 1, 1, and 8 adding up to 10, which is not allowed by normal Sudoku rule, so this must be a 4, which makes that a 1. That makes this 2, which makes that a 3. This is 1, 4, and 7, which adds up to 12, so this must be 5, adding up to 17. This can't be 4, so this must be 2, which makes that a 4. 4 adds up with 1 to add up to 5. So this can't be 1 or 4, which means this can't be 6 or 9. This can't be, this has to be a 3 to add up to 5. This can't be 3, so this is 1, which makes this a 9. This cannot be 1, 6, or 3, 4, so this must be 2 and 5. Which means this can't be 2. This has to be 4, which can be next to 3 or 5. This can't be 2 or 4, so this must be 6. Well, this is 10 already, so these two digits must add up to 7. So it's either 2, 5, or it's 3, 4, but it can't be 3, 4, because we already have a 4 here, so this must be 2 and 5. This can't be 6, so it can't be 4, 6, which makes this 1 and 9. The 1, 9 removes 1 and 9 from the rest of the box as a possibility, so this can't be 1, 9, so this must be 4 and 6 here. These three digits add up to 17. These three digits add up to 17, and these two digits add up to 8. So 17 times 2 is 34, plus 8. 34 plus 8 is 42, so that leaves a 3 here. So this is 3, which means the remaining digits are 4, 5, and 8. And this can't be 4. This can't be 4, so this is 8, which makes that a 4. This can't be 8, so this must be 5. This can't be 4 or 5, so this is 8, which makes that a 4. This can't be 3 anymore, which means 3 has to be one of these two cells. And this can't be 1 or 5, so this is 3 or 7. The remaining digit in row 8 has to be a 9. The remaining digits here are 1 and 7, and this can't be 7, so this is 1, which makes that a 7. Remaining digit in column 3 is a 2. Remaining digits in column 1 is 1 and 3, but it could be either of those. Okay. One of these is 8. The other one has to be 3. So this is 3 and 8. The remaining digits here are 4, 6, and 7. And this can't be 4 or 7, so this is 6. This can't be 7 or 6, so this is 4, which makes that a 7. This can't be 6 anymore, so this is a 2. And the remaining digits here are 1 and 5. Which means to add up to 17, you have 1, 2, 5 already. That means you have to have 3 and 6 left. So this is a 3 and this is a 6. Right? Because it's either 1, 2, 3, 4, 7 or 1, 2, 3, 5, 6. And since this is a 5, this has to be 1, 2, 3, 5, 6. This becomes 7 or 8. And this is 4 or 9 here as the remaining digits. This 1, if it were here, has to be next to a 2, but we already have a 2 in the column, so this can't be 1, which means this can't be 9. This adds up to 12. This adds up to 11, right? 2, 3, and 6. These three digits add up to 17. So 12 plus 11 is 23, plus 17 is 23 plus 17 is 40. So therefore this must be 5, because 45 minus 40 is 5. So this is 5, which makes this 1, 7, and 9 to add up to 17. This can no longer be 9 because of the 1, 7, 9 triplet in the box. Also, this can't be 1 or 7 because of this 1 or 7, so this must be a 9. Which means this can't be 9 or 7, so this is a 1, which makes this not a 1 or a 9, so this is a 7. This 1 means this can't be 1, so this is 9, which makes that a 1. Again, this can't be 9, so this is 4, which makes that a 6. And for these two digits adding up to 10, 1, 9 is removed, 3, 7 is not possible, and 4, 6 is not possible, so this must be 2 and 8. This can't be 2, so this is 8, which makes that a 2. This can't be 8 anymore, so this must be 7, which makes that an 8. This can't be 7, therefore this makes this a 7. This can't be 4 because of this 4, so this is a 9, which makes that a 4. This 8 means that can't be 8, so it's a 5, which makes that an 8. The last digit in row 4 is a 3. And we have 1 or 5 here, but this can't be 1. So this must be 5, which makes that a 1, which makes that 5. That makes this a 6 as the only remaining digit in box 6. Oh, and this is box... We number boxes by normal Western reading notation. So this is box 1, 2, 3, 4, 5, 6, 7, 8, and 9. In column 8, the only remaining digits are 1 and 9. So this could be either. We actually have 8 2s, right? So we can know where the last 2 is. It has to be here. 5s, we have 8 5s. So we know where the last 5 is. It has to be here. What about 3s? This can't be 3, so this must be 8, which makes that a 3. I think that gives us 7. So unfortunately, that's not enough. What about 4s? We have all 9 4s. 5s. We have all 9 5s. 6s. We don't have enough there. 7s. We have all 9 7s and 8s. We have... Well, we have in box 5, 8 can't be here, so 8 has to be here. Which gives us 8 8s now, and we know where the last 8 is. It has to be here. This is 1, 3, or 9. Okay, this is specifically 6 or 9, and this can't be 9, so this is 6, which makes that a 9. None of these can be 9, so this must be a 9 here, which makes that a 1, which makes that a 9. This 1 means this can't be 1, so this is 3. That's a 1. This has to be a 6 remaining, and this is a 3. Oh, wait, not a 3. This is a 3 remaining, and this is a 6. I don't know why I switched it there. Anyways, yeah, that's how you solve it. Pretty straightforward. I almost got through. I always do this sometimes with the region sum lines. I sort of see these, and then for some reason I equate the whole of this region sum to these digits here when it's actually all 5 of these. So be careful about that when you do region sum lines. I do it a lot, so I know it's something that solvers can fall into that trap. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.